Ladies and gentlemen, we want to start the most important thing in linear programming. Most important. The essence of this is that you have to master the formulation than the computation. It's the formulation that is critical. But your understanding of the formulation is very important, and this is dependent. We're going to treat a topic known as a fixed charge in linear programming. Fixed charge. It is an integer linear programming. Full stop. You might remember that the objective function, whether it's a minimization, is formed by connecting a coefficient with a decision variable. Do you remember? Connecting coefficient with a decision variable. Now let me show you. That's the screen. Connecting coefficient with a decision variable. The coefficient, so anytime we are normally writing our decision variable, let me just go to the notes here. Okay. Normally, we say that the objective function is equal to z max or z min is equal to the objective coefficient multiplying the decision variable. So every objective coefficient is multiplied by every decision variable. Okay. And that is how we find our analysis. Now, is this principle here is this. That objective coefficient, it can be a cost, it can be a profit. But in some cases, you got to decide to produce, and that decision to produce will lead to a lump sum tax or a lump sum amount. Now, I want to come back to that. The objective coefficient, and you got to pay attention here because sometimes this can be slightly good. The objective coefficient means that it is possible to generate this coefficient provided you are going to produce the decision variable, isn't it? So you see that each decision variable is there because this objective coefficient is there. So this objective coefficient, if it is say a cost, it will be like the variable cost of producing the decision variable. So you can have a decision variable, say x1. But that x1 is producible because you are incurring a cost of 20. So you get 20x1. So the 20 is like the variable cost. So as x1 is increasing, you have to incur more cost. Now let me just take you back a little bit to economics. Because taking you back a little bit to economics will help you. In economics, we have total cost. And total cost is equal to fixed cost plus variable cost. Now, the variable cost, I can draw it like this. This is the output, and this is a variable cost. And the variable cost is in such a way that it moves somehow like this. Okay, so this is the cost, more or less, and this is the variable cost. So the variable cost moves that way, which means that as long as you are producing from 2 to 10, the variable cost will be rising, say, from 5 to 20. Okay. So it rises with production. The more you produce, the more variable cost you incur. This is economics. So have that in mind. Now, there's another cost which is known as fixed cost. So let me put that one here. Okay. Let me color that slightly. Okay. Fixed cost. Fixed cost. Okay. That one is like this. So let me say fixed cost is something at 4. Fixed cost is that cost you incur whether or not you have produced. So if you are starting a business, you buy the house, the building, in order to stock your items. Whether you started selling or not, that cost is already borne. A fixed cost, that's why you can see, irrespective of the number of production, as you produce, keep producing, that cost is still is borne already. The cost is fixed. This kind of fixed cost, in our parlance of integer programming, is known as the fixed charge. The fixed charge is an important kind of principle that we are going to do. Okay. Now, you again, it's very important that you are really paying attention to what we're about to discuss. So let's go. There is a trick when you are analyzing fixed cost or fixed charge. Here can be used to formulate many location and production problems as an integer program. Okay. In a fixed charge problem, and we're going to look at an example. There is a cost associated with performing an activity at a non-zero level. I've already said that. You still incur a cost even when you perform the activity at a non-zero, that is at a positive level. So you're still producing, okay, and that does not depend on the level of production, or in this case, the level of activity. Just as there is a fixed cost which is independent of the level of production. The best way to incorporate fixed cost into this production analysis is by taking an example. And I'm going to read an example step by step, slow by slow, explain to you how you can incorporate this in your work. So let's take an example, and I'll be walking you through it step by step. If at each point you are not clear, raise your hand, and then I will come back to it. Textiles Limited manufactures 3 types of clothing: shirts, shorts, pants. If you're manufacturing this, each type of clothing requires that the company has the suitable type of machinery available. I want you to take note of the word requires. So each type of clothing, that is, each shirt, short, pant, before you can produce it, you need to, it is by force that a certain suitable type of machinery got to be available. Suitable type of machinery got to be available. The machinery needed to produce each type of clothing, or in short, the machinery needed to produce shirt, short, pants, must be rented at the following rate. The shirt machinery should cost 200 cedis every week. The short machinery should cost 150 cedis every week, and the pant machinery should cost 100 cedis every week. So those are the costs. Now that should again tell you that these costs are costs that must be there before, or must be incurred before you do your production, because they are machinery, and the fact that you buy the machinery, you incur that cost, doesn't mean you've done your production. So those costs have to be borne. Whether or not you are going to produce to make money, that cost has already been incurred. Now, continue. Manufacturing also requires the amount of cloth and labor shown below. So before you can produce, okay, now you're going to produce, you need certain kinds of cloth and labor to produce. Now that is what's down here. So let me quickly go through that first. So if you are going to produce shirts, okay, if you are going to produce shirts here, the hours of labor needed is 3 hours, and the square yards of cloth needed is 4 square yards. The same way, if you are going to produce pants, you need 6 hours of labor and 4 square yards of cloth. So keep that in mind. So these are the things you need. But then he gave you the limitation. He says that every week, each week, 150 hours of labor and 160 square yards of cloth are available. And we've been noticing that anytime something is available, that is a limitation. That is less than or equal to. Now, this is interesting. The variables unit cost. You see, he's not telling you the unit cost, like if it was in economics, the variable cost. So the variable cost and the selling price for each type of clothing are shown in the table below. Okay, so let's go to the table below. So you have the selling price, which is the price, and then here is the cost, not the fixed cost, but the variable cost. The question is simple. Formulate an integer programming problem whose solution will maximize the weekly profit. Now, usually what we do is that we try as much as possible to understand the decision variables. So let's try to understand the decision variables from here, or here, the table, any one of them. Okay, how would you have written the decision variable? Let what be what? Let what be what? Who can tell us? Let what be what? I'm going to just keep it here. Let what be what? Let x1 be what? Who can guess? Because how you indicate that is important for our understanding. Let x1 be what? So what are we deciding on? We are deciding on the number of each type of clothing. Let me take you back to the storyline, and then it will help you here. It says that the variable unit and cost selling price, blah, 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 formulate an integer programming whose solution will maximize the profit. Okay, let's go back. It says the manufacture of each type of clothing requires the following, blah, blah, blah. Each type of clothing. We are going to manufacture each type of clothing. And that is our decision. So X1 will be what? How would you formulate the X1 principle? How would that be if you were to formulate the X1? What would be the decision? X1 will be the number of, exactly, Kajitan has indicated, the number of, that is, if you use your mind to quickly crack that, that is fantastic. X1 will be the number of shirts, okay, to produce. That's it. That's X1. So the X1 will be the number of shirts produced each week. The number of shirts produced each week. X2 will be the number of shorts produced each week. X3 will be the number of pants produced each week. So that is what you have as your decision variable. Okay. If you understand this, you are good to go. But there was a clause. Do you remember that before you can produce this, you need to have incurred a certain cost, which was a fixed cost? Do you remember? So there is a cost of renting a machinery. And that cost of renting the machinery only depends on the type of clothes. Okay? And this point is very important. So let me show you this in the slides. So you need to incur some cost of the machinery. But don't just go and buy a machinery which is not for shirt. So before you go and buy the machinery, and you remember there was some amount attached to each machinery. It says that shirt machinery will cost $200. You got to rent it. But you don't go and just rent shirt machinery when you know you are not going to use it for shirt production. So whatever machinery that you are going to incur, you see, so again, you got to make a decision on the kind of machinery you are going to what? Rent. That in itself is a decision, and it's a decision variable. Okay, so let's go back down there. So the cost of renting that machinery depends only on the type of clothes. It's not on the amount or the number of clothing you are buying. Okay, so it's not about how many of the shirts I'm going to what buy before I now decide to know this thing I'm going to, this machinery I'm going to rent. As long as I know I'm going to produce shirt, I go for this machinery. It's not about whether I'm going to produce 20 shirts or 200 shirts. No. So before I rent that machinery and pay for it, I gotta know that I am going to use that machinery for the production of this type of clothing. And so gotta decide on the kind of machinery I'm going to buy. But because that decision depends on the shirt, that is on whether I'm going to produce shirts or not, Okay, that is an important element. So first thing is this: I got to decide on machinery to buy. Okay, and that machinery I'm going to decide is why I'm going to decide. But it's for each what? Each clothing production. So I am going to have Y1 if I'm going to produce what? Shirt. I'm going to have Y2 if I'm going to produce shorts. I'm going to rent Y3 if I'm going to rent what? If I'm going to produce pants. And so you can see that these Y's are dependent on the shirt. So if I am not going to buy shirts, if I'm not going to produce shirts, I don't need to buy Y. So Y being there or Y occurring depends on whether or not I will produce what? The clothes. So Y1 occurring depends on whether I will produce shirts. Y2 occurring depends on whether I'll produce shorts. So Y becomes a binary. So Y is 1, that is it being there, provided if X1 is what? Is positive. So if X1 is going to be there, then Y, if X1 is going to, if I'm going to produce shirt at all, that is when Y1 becomes available. But if not, I can say 0 otherwise. So if I am not going to even produce shirts, it's not about the number of shirts I'm going to produce. I'm not even going to produce shirts. Then I don't need that machinery. Then I don't need the Y1. So Y1 becomes a binary variable. The same way Y2, I cannot actually bring about Y2. So Y2 is 1 if X2 is going to be happening. And Y2 is going to be 0 if X2 is going to be what? 0. So the Y's are integers. Okay. And Y3 is also 1. Okay. Of course, you can do this. It's equal to 1 if this and equal to 0 if the other one happens. So these are integer programs, and you got to define them accordingly. So let's just go back here. So Y1 is 1 if shirts are produced, and Y2 is 0 if shirts are not produced. Y2 and Y1 is 0 if shirts are not produced. Y2 is 1 if shorts are produced, and 0 otherwise. The same way Y3 is 1 if I'm going to produce pants, or 0 otherwise. I think you get it, because this is a critical. So this means that we need to have that Y in mind. These are important. Okay. So on the basis of this, we can now write our formulation. Okay. Let's take us back to our formulation here. Okay. Look at our formulation. Our formulation says that we are going to maximize profit. Okay, TTL profit. Now, remember, there was something that has been given to us here, and this is usually carries an economic principle. Okay, so let me just go back here and then show you what I mean by it carries an economics principle. It has carried an economic principle, and sometimes once you understand. So I'm going to have my Z max, which is my profit, but then you have to understand some few things. This profit is the revenue minus the cost. Total profit is the total revenue minus the total cost. Okay, that is a profit. Total revenue minus the total cost. Now, why do I even have to think about total revenue in the first place? Well, you got to think about total revenue in the first place because you were told that the revenue and the cost are as follows. And you have sales price, and you have, the variable cost price and all of that. Now, what is revenue? What is the total revenue? If your economics is very good, you will know that the total revenue is always the price times what? Times the quantity. Okay, price times the quantity. And then the total cost is actually the fixed cost as well as what? The variable cost. The fixed cost as well as the variable cost. So let's deal with the total revenue first. The total revenue is price times quantity. Price times. So what is the price? Go back to the table. Okay, and you were told that for each of the shirts and shorts, there's a price of 12,815. Okay, and what is the quantity? The quantity are the X1, the X2, the X3. These X's that you don't know their values yet. Okay, which in our previous situation here, watch it. We have represented them by X. They are the quantities. So these are the quantities that we are going to look out for. Okay. Those are the quantities. So on the basis of that, we can write our, let me make it equal to, okay. So we can write our individual revenues to be the price times the quantity. And of course, please don't forget the price. The prices were 12, 8, and then 15. 12, 8, and then 15. So I'll just go back here and I'll write 12 x1 plus 8 x2 plus 15 x3. Okay. So these are my what? These are my price times quantity. Now let's go to the total cost. The total cost, okay, we have to deal with the variable cost first. So let's deal with the variable cost. Now, if you have a question, you just ask in there. Yes, total cost is variable cost plus fixed cost. But you see, I'm subtracting it. I agree with you. But watch the top there. I'm subtracting it. Okay, I'm subtracting this whole thing there. So it is total revenue minus the total cost. So even though total cost itself is a fixed cost plus variable cost, but I'm subtracting it, so that minus will affect both the fixed cost and the variable cost. Okay, unless I bracket it, but I decided not to bracket it because I want to apply the minus to both of them. I hope you understand. Okay, I hope you understand. So if you want me to bracket it, I'll just do it, okay, for your understanding. So you do that and then you have to bracket it. Okay. But eventually remember that the minus is going to be applied to all of them. Okay. So let's bring the minus. And I'm going to deal with the fixed cost first. Okay. I'm going to put that in a bracket so that you get it. The variable cost first. I'm going to deal with the variable cost. Now the reason why I'm going to deal with the variable cost is because the variable cost multiplies the kill. If you can remember, variable cost is that kind of a cost multiplying the quantity, which is the X's. So there must be a certain variable cost multiplying quantity, a certain cost multiplying the quantity. Well, we go to the story, and you can see here that there is a variable cost, 648, and they will surely be multiplied because you can't incur a variable cost unless you are producing. The fact that it's variable means it's changing. It's changing with respect to something, and that something is the decision variable, the X's, the quantities. Okay, so on the basis of that, you will now have the values of these, which are what? 648. So you have 6. Let me just go back. You have 6 x1 plus 4 x2 plus 8 x3. I've still continued the bracketing. Okay, and then you will have the next one, which is what? The fixed cost. Now, what is the fixed cost? Well, let's go back. We told you that the fixed cost is y1, y2, because remember we said that it is a machinery, and that is a binary. It's a machinery. Okay, and so the temptation is this, and it's very important. The fixed cost here must be, if y1 is going to be 1. And let me just go back here. If y1 is going to be 1, okay, sorry, if x1 is there, if the shares are going to be produced, then y1 is going to be there. And the cost associated with that y1 was in the storyline. Go back here and you see, you were told that 200 for the shirt, 150 for the shorts, and 100 for that. So 200, 150, 100, they have to be incorporated. Each one must be multiplying the y's. So let's go. So you're going to have 200. I'll put that in a bracket as well. So you have 200, not x1, but y1, okay, plus 150 y2 plus 100 y3. So these also have to be incorporated in the analysis. So at this stage, our final Z max is going to be equal to, now you can see that there are some like terms here, 12x1 and then 6s1. Remember, there is a minus affecting them. So it's going to be minus 6s1. 12x1 minus 6s1 will give you what? 6x1. Okay. Plus 8x2 here, 4x2, they are like terms. One is going to be minus. So it will be 8 minus 4. That will give you what? 4x2. Then plus 15x minus 8x3. That will give you 7x3. Then you bring your minus the y's. Okay? So you're going to have minus 200y. Those are not like terms, so you can't do anything. Minus 150y2 minus 100y3. So this becomes your complete Z max. Don't worry about why do we have y's here, because you understand where we are coming from. Just that it looks a little bit complex, but we know why we are where we are. Now that you've done the formulation, we now go to the constraint. So this whole thing, we are going to maximize it subject to the constraint. And go back to the story. And these constraints are not difficult initially. Okay? Go back to the constraint. It says that the constraints are, we were clear, each week 150 hours of labor, 160 square yards of cloth. So labor and cloth are the constraint. Okay? And they were given right here. So for labor, attached to the excess, okay, we have 326. And for cloth, attached to the excess, 434. Okay? So you can add that easily into the constraint. So let's go. Okay. So subject to, and then the labor, we do the labor constraint first. Okay. That is what? 326. So you have 3, x1, 2, x2, 6, x3. And according to the thing, it should be less than or equal to 150, isn't it? Less than or equal to 150. So you do 150. That is for the labor. So this is the hours. The next one was the cloth. And the cloth, I can remember without a doubt that that was an amount of 160. So I'll put that 160 on the right hand side. And then the values, what were the values? Let's go and check the values. Okay, the cloth. So the cloth, you have 434. 434. 434. So let's go to our analysis. So that is going to be 4x1, 3x2, and then 4x3. That's it. So we now have these constraints, okay? And that means that we've been able to incorporate the constraints into the picture. Now, it is very important to understand something very, very quickly. It is very important. And this is why it is very important. If we go and solve this, equation, okay, if we solve this equation, where, of course, we have to decide which ones are non-negative. Now, the non-negativity constraint, we have to bring here x1, oops, x1, x2, okay, x3. These are non-negativity constraints. Okay. But if you can see clearly, these are also what? Integers. Do you realize that? So it's greater than 0 and integer, because you can't have half shirt and all of that, quarter shirt and all of that. Okay. So these are integers. And then the y's, what do you think they are? Who can tell me? The y's are what? Somebody should type it there for me and tell me. What are the y's? Okay. The y's are going to be what? Interesting. Okay, binary, exactly. The y's are going to be binary because they will depend on whether this one. Okay, so these ones, the y's are going to be, now we don't say greater or equal to. Yeah. Equal to 0 or 1. Okay, so the y's are binary. And when you have this formulation right here, then it will look like, you are in a comfortable lead. That's what it will look like. So let me show you something here. Let me show you something in the slides. These are the formulation. So you have the Z mass formulation, and then you have the binary, and then the integer constraints. That's what you have there. Now that integer constraint is known as the integrality constraint. The question we need to ask ourselves is whether this whole formulation is correct. Is this formulation correct? Yeah. Is it correct? Who would tell me yes or no and why? Is this formulation correct? Okay. Of course, let me take you back to where we were before, because this one might look a little bit, but here, which is where we were. If you look at this, this very formulation, is it correct there? What do you think? Is it correct? So somebody says it is both correct and wrong. Let me tell you the solution. If you should solve this thing in Excel, of course you can do it later. The optimal solution to this integer programming, and if you check it in Excel, is going to be x1 is 30, there's no x2, x3 is 10, y1 is 0, y2 is 0, y3 is 0, and the x2 is also not there. If you formulate this in Excel, that's what you get. What is the problem here? If you formulate this, okay, this formulation, okay, if you formulate it, this is what you get. Is that correct? And what is the problem with it? Michael, are you there? Is that correct?
Doc, I'm here.
Yes, go ahead.
Yeah, so I think that the problem is that y1 and y3 can't be 0 because we produce some shirts and some pants, and so their fixed cost cannot be 0.
Correct. Correct. You can't produce x1 30 when you are incurring 0 y1. Neither can you produce x3 to be 10 when you are incurring 0 machinery cost. It doesn't make sense. It doesn't make sense. Well, y2 is 0, so x2 not being there, that one is fine. That one is fine. But the others, they don't make sense. Okay. And the reason why they don't make sense is that you can't produce without incurring a rental cost. Now, the reason is because we did not account for the y's in the constraint. You know, anytime you do your formulation, whatever decision variables that are counted inside the objective function, those decision variables also have to come into the constraint. And I mean the formulation of the constraint themselves, not the integrality or the binary constraint. No, not that one. Not a standard one. But they must be incorporated in a constraint. The same way the x's are incorporated in the labor and cloth constraint, this also have to be incorporated. And the incorporation of these, ladies and gentlemen, the incorporation of these into the formulation is what makes fixed charge an interestingly complex and beautiful, formulation. And so we are going to do that. And at this stage, you want to really pay attention to know how this incorporation is done, and finally how we arrive at our final constraint.